students, in this video we shall continue with differentiation 1.3. We are going to deal with the implicit functions. What are the implicit functions? Up till now we have seen the functions were like y equal to some function of x, for example sine 2x. This is called explicit function of x. Y is explicit function of x. Now here there is no y equal to function of x. X and y are mixed up here. Implicit function of x and y. Now from this we have to find dy by dx. So let us see how to find. Method is the same. We have to find derivative and we have to keep dy by dx on left hand side and rest of the terms to be transferred on right hand side. So question number 1. Now see, x root x can be written as x raised to 3 by 2 plus y raised to 3 by 2 is equal to a raised to 3 by 2. And now we can use the derivative. Differentiate both sides with respect to x. We get 3 by 2 x raised to 1 by 2 plus 3 by 2 y raised to 1 by 2. Derivative of y raised to 3 by 2 is 3 by 2 y raised to 1 by 2. Chain rule. In place of x we have y, so into dy by dx is equal to, this is a constant, so derivative is 0. Now this is a term containing dy by dx. We keep it on the left hand side and rest of the terms we transfer on right hand side. So we get 3 by 2 y raised to 1 by 2 is root y into dy by dx is equal to, on right hand side it becomes minus 3 by 2 x raised to 1 by 2 is root x. Now cancel 3 by 2 from both sides, so it is minus root x, and then for finding dy by dx we divide by root y, so minus of root x upon root y is the solution for the first question. Now students, see the second one. It seems to be a difficult one. There are two inverse functions, then chain rule, but if we know inverse trigonometry and we know tan inverse x plus cot inverse x is equal to pi by 2. If this result we know, we can transfer this minus on right hand side. We get tan inverse root x square plus y square plus cot inverse root x square plus y square, and that is equal to pi by 2. And so the question reduces to x square y square equal to pi by 2. Now this is a constant. We just differentiate this side with respect to x. Product rule. U into v. U, derivative of y square is 2y, chain rule, dy by dx plus y square into derivative of x square is 2x. Constant, derivative is 0. Now this is term of dy by dx. So we write 2x square y dy by dx on left hand side is equal to, now this term goes on right hand side, it becomes minus 2xy square, and so students we get dy by dx equal to minus 2xy square upon 2x square y. 2 gets cancelled, 1x gets cancelled, 1y gets cancelled, and we get minus y upon x. This is the answer. We move on to the third one. Again implicit function. So method is the same. Differentiate both sides with respect to x. So for third one we get, now this is one term, product rule, x derivative of e raised to y is e raised to y, chain rule, dy by dx. Follow this, u derivative of v plus v derivative of x is 1, so this is first term, plus again u into v, u derivative of v, derivative of e raised to x is e raised to x, plus e raised to x into derivative of y is dy by dx. On right hand side derivative of constant is 0. There are two terms containing dy by dx, so we write x e raised to y plus e raised to x into dy by dx. What we have done is, we have taken these two terms together, we have taken dy by dx common, and in the bracket we get x e raised to y plus e raised to x. The rest of the terms we shift on right hand side, both are positive here, they will become negative. We write minus common and we can write e raised to y plus y into e raised to x. Now to find dy by dx, what we have to do is divide by this bracket on right hand side. So minus e raised to y plus y e raised to x upon x e raised to y plus e raised to x, and this is our final answer, dy by dx. Now students, for the fourth question, method is the same, implicit function. So we differentiate term by term and see what do we get. On left hand side we have to use the product rule. X, derivative of sine is cos of x plus y, but in place of x there is x plus y, so chain rule, derivative of x plus y is 1 plus dy by dx. This is first term, u derivative of v, u derivative of v plus v sine of x plus y into derivative of x is 1. So this is left hand side complete, is equal to, on right hand side first term is y, derivative of y is dy by dx minus, now derivative of cos is minus sine, so minus minus becomes plus, sine of x minus y, chain rule, derivative of x minus y is 1 minus dy by dx. We open the brackets wherever required and let us see, x cos x plus y into 1 plus x cos of x plus y into dy by dx plus sine of x plus y, this is left hand side, is equal to dy by dx as it is, sine x minus y into 1 is plus sine of x minus y, and sine x minus y into minus dy by dx is minus sine x minus y into dy by dx. Now how many terms contain dy by dx over here? This is one term, this is on left hand side, this is the second term, this is on right hand side of the equation, and this is third term. So there are three terms containing dy by dx. We take all these three terms on left hand side, so this will come on left hand side minus dy by dx, this negative will come on left hand side, will become plus, and from all these terms, if we take dy by dx common, in the bracket we are left with x cos of x plus y minus 1 plus sine of x minus y into dy by dx. So on left hand side we have obtained all terms of dy by dx, and on right hand side we write all terms without dy by dx. So this is the first term, sine of x minus y on right hand side. This is another term which we have to shift on right hand side, minus sine of x plus y, and this is the third term we have to shift on right hand side, that is minus x cos of x plus y. So this bracket into dy by dx equal to these three terms. Now to get the value of dy by dx, what we have to do is we have to divide by this bracket on right hand side. So answer becomes sine of x minus y minus sine of x plus y minus x cos of x plus y whole upon this bracket, that is x cos of x plus y minus 1 plus sine of x minus y. These terms do not get cancelled, note, because this is plus and minus. So this is our final answer. So this is question number 4. Now we move on to question number 5, 6, 7, 8. Question number 5. Again we see on both sides there are terms of x and y, implicit functions. We can use product rule and solve, that is okay, but the problem is simplified if we use log. Why? Because there is a product of two terms with pause. So let us take log on both sides. Log of x raised to 7 y raised to 5 equal to log of x plus y raised to 12. Now students, using formula of log, we get log of x raised to 7 plus log of y raised to 5. Log m raised to p is p log m. So 12 log of x plus y. On left hand side also we can write 7 log x plus 5 log y is equal to 12 bracket 12 into log of x plus y. And now we differentiate each term with respect to x and see what do we get. 7 upon x, 5 upon y dy by dx is equal to 12 upon. Now derivative of log x is 1 upon x. So derivative of log x plus y is 1 upon x plus y. Chain rule into derivative of x plus y is 1 plus dy by dx. Now students, we open the bracket and write 7 by x plus 5 by y dy by dx equal to 12 upon x plus y plus 12 upon x plus y into dy by dx. We see there are two terms of dy by dx. We take this on left hand side, we take dy by dx common from this, and in the bracket we can write 5 upon y minus 12 upon x plus y. On right hand side we get 12 upon x plus y minus 7 upon x. Now see students, left hand side can be solved, cross multiply. In the bracket we get 5x plus 5y minus 12y upon y bracket x plus y into dy by dx. And on right hand side we get 12x minus bracket because minus 7 times this. So we write 7x plus 7y. Check these brackets are important, into x bracket x plus y. Now see, both sides in the denominator there is x plus y gets cancelled. I am writing this answer at the top. So what we can write here, 5x, 5y minus 12y, that is 5x minus 7y upon y into dy by dx. Check right hand side, what do we get? This is 12x minus 7x is 5x minus 7y upon x. Now this numerator 5x minus 7y on both sides gets cancelled and we get dy by dx equal to y by x. So students, this is for question number 5, an important question. Now let us move on to question number 6, 7, 8. Now all these questions 6, 7, 8 are similar, same method for solving all this. There may be two methods possible, we shall be using one of them. Now see students, if we directly take derivative of sec x is sec x tan x. In place of x we have this bracket. So chain rule, derivative of this bracket and so on. Problem becomes too lengthy and also answer won't match. The question may be prove that dy by dx equal to y by x. So that is very difficult to prove unless we use this first step. On right hand side there is a constant. So we just transfer this sec on right hand side. Sec of this equal to a square. So this bracket is equal to sec inverse of a square. So what do we write? X square plus y square, sorry, x raised to 5 it is, x raised to 5 plus y raised to 5 upon x raised to 5 minus y raised to 5 equal to sec inverse of a square. Now since a square is a constant, sec inverse a square is also a constant, and let us denote this constant by k. So we have x raised to 5 plus y raised to 5 upon x raised to 5 minus y raised to 5 equal to k. We can cross multiply and then take the derivative and all, that is possible. But we use one method which we have seen in 9th and 10th standard, ratio proportion. If a upon b equal to c upon d, two ratios are equal or a, b, c, d are in proportion, then we can use componendo dividendo. What is componendo dividendo? It is on left hand side, if we perform a plus b upon a minus b, it will be same as equal to c plus d upon c minus d. So if a upon b equal to c upon d, then a plus b upon a minus b equal to c plus d upon c minus d. This is called componendo dividendo. In CBSE 9th and 10th standard, you might not have seen this. In state board, you have learned this in 9th standard. So if you are CBSE students for standard 9th and 10th, then please note this property. This is called componendo dividendo. Learn this and we shall be using it over here. So let us use componendo dividendo. So in componendo dividendo, we have to add this denominator to the numerator a plus b, and then subtract this denominator from the numerator a plus b, a minus b. Same we shall do here. So x raised to 5 plus y raised to 5 plus x raised to 5 minus y raised to 5 upon x raised to 5 plus y raised to 5 minus x raised to 5 minus y raised to 5 on left hand side componendo dividendo. So this is k plus 1 upon k minus 1. And so students, on solving left hand side, we get y raised to 5 gets cancelled, 2 times x raised to 5 upon, here x raised to 5 gets cancelled, 2 times y raised to 5 equal to k plus 1 upon k minus 1 is again some constant. Let us denote that constant by lambda. This 2 gets cancelled and we get x raised to 5 upon y raised to 5 equal to lambda, that is x raised to 5 equal to lambda into y raised to 5. Now this is simple problem for derivation. Let us differentiate this with respect to x. Check what do we get. 5x raised to 4 equal to 5, lambda is a constant, we write lambda as it is, 5y raised to 4, chain rule, dy by dx. This 5 gets cancelled on both sides, and students, we get dy by dx equal to, we have to transfer this lambda y raised to 4 in the denominator, so we get x raised to 4 upon lambda y raised to 4, that is equal to 1 by lambda into x raised to 4 upon y raised to 4. Now see, this lambda is equal to x raised to 5 upon y raised to 5. So if we take 1 upon lambda, it will be reciprocal, that is equal to y raised to 5 upon x raised to 5 into x raised to 4 upon y raised to 4. So answer is y upon x, that is dy by dx. In all these questions, we will be getting the same answer. Method is the same. Try to understand this componendo dividendo and the problem becomes easy. Let us move on to question number 7. Now it is log of some term is equal to 20. There is no base given. We can say base is e, and to remove this log we can use this bracket is equal to e raised to 20. So we write x raised to 20 minus y raised to 20 upon x raised to 20 plus y raised to 20 is equal to e raised to 20, which is a constant. We write it as k. Now again we have plus minus terms in the numerator denominator. So let us perform componendo dividendo. By componendo dividendo, what do we get? X raised to 20 minus y raised to 20 plus x raised to 20 plus y raised to 20 upon x raised to 20 minus y raised to 20 minus x raised to 20 plus y raised to 20 is equal to k plus 1 upon k minus 1, and we denote this by some other constant lambda. So on left hand side we get 2 times x raised to 20 upon, here x raised to 20 gets cancelled, minus 2 times y raised to 20 is equal to lambda. Cancelling this 2, we get lambda equal to minus of x raised to 20 upon y raised to 20. Now let us cross multiply this. So we get x raised to 20 equal to minus of y raised to 20 into lambda. We have taken this minus on the right hand side. Differentiate with respect to x. So 20 x raised to 19 equal to minus, lambda is a constant, 20 y raised to 19 chain rule dy by dx, and so students we get dy by dx equal to, this 20 gets cancelled and we can write x raised to 19 upon minus of lambda into y raised to 19. Now this is dy by dx equal to minus lambda. This is 1 upon minus lambda. Lambda is equal to negative of this. So minus lambda will be x raised to 20 upon y raised to 20. So 1 upon minus lambda will be y raised to 20 upon x raised to 20. Y raised to 20 upon x raised to 20 into x raised to 19 upon y raised to 19, and solving this we get y upon x is equal to dy by dx. So method is more or less same for all such types of questions. The next one, 8th. Again, if we directly take the derivative, it will be very difficult. We won't get the answer maybe. But if we transfer this cos inverse on right hand side, it will become cos of something, and the problem becomes 7x raised to 4 plus 5y raised to 4 upon 7x raised to 4 minus 5y raised to 4 is equal to cos of tan inverse A. Tan inverse A is a constant, so this is again some constant k. Again plus minus terms we see, so we use componendo dividendo. So 7x raised to 4 plus 5y raised to 4 plus 7x raised to 4 minus 5y raised to 4 upon 7x raised to 4 plus 5y raised to 4 minus 7x raised to 4 minus 5y raised to 4 is equal to k plus 1 upon k minus 1, again a constant, we write it as lambda. On left hand side we get 7 plus 7 14 x raised to 4 upon 7 plus y raised to 4 is 10 y raised to 4, 14 x raised to 4 plus 10 y raised to 4 equal to lambda, and so we get 14 x raised to 4 equal to lambda into 10 y raised to 4. Now students, if we differentiate this, we will get 14 constant 4 times x cube equal to lambda constant 10 constant 4 times y cube dy by dx, and check what do we get. Now dy by dx on one side equal to, we have to divide by this complete term.